All right, our next speakers today are Lars Roepstorff and Oliver Hoberg. They're going to be talking. One of the reasons I'm particularly excited about this is Lars and Oliver have built a team that allows them to take the information that Lars is doing with the measurements and in real time adapt the surface to the information that's coming in. And they've got several good examples here of where they've done this at high-level events and been able to seamlessly integrate the new information that's needed. So I'll turn it over to Lars.
Thank you very much. Thank you for being invited. Yes, so I work at the Swedish University of Agricultural Sciences with biomechanical research, and of course with one important line with the footings. Oliver Hoberg, who is with me and who is going to listen to also, is an independent footing expert. So I think I'm correct when I say Oliver is the one who has overseen being FEI, the International Equestrian Federation's expert and advisor to great championships, to Olympics, to World Equestrian Games, and to championships around the world, literally. So, I mean, he's a guru when it comes to going out there, touching the sand, adjusting the groomer, adjusting the water level, and so on. So it's been a pleasure for me to be working with Oliver for a number of years, and it's been very encouraging that someone with that kind of experience actually sees the advantage of getting some figures. But maybe it's because it is easier to measure the surface if you know that you measure something that is actually relevant for the horse and the rider, instead of interviewing 50 riders, because that's what you have to do at least if you want to have an average of what you think, because whether you are a jockey or an equestrian rider or a catch driver or whatever it is, there will always be a lot of opinions. Or anyone who has any other experience than that? No, I don't think so. Okay, so I'm very happy for Raul's presentation before lunch. It was really the thing that I would use to start to present. So now you have all the science behind it, and we can jump into some of the very practical stuff. So this is one version of the OBST that you will see later on this afternoon. And this was from Tokyo Olympics now this last summer. So this OBST, you heard a little bit about the background. The important thing is really that this is a mechanical hoof, a robotic horse limb that mimics the hoof landing speed, the loads, the load rate. Load rate is very important in this situation, because surfaces that we work with, which are more or less all sand-based, they have the viscoelastic properties. You know what that means? It means that it changes its actually how it deforms when it gets loaded, depending on load speed. So I hope I don't, or maybe I push some what we see, sore feet, we say in Swedish, if I say that. This is the reason that a Clegg hammer is not a very good tool to test surfaces for horses, because you need to have the same peak forces, you need to have the same load rate that a horse exhibits, or else you can't really measure what the horse feels. So this is what Mick has put a lot of work into and developing this, and I've been lucky enough to develop it further and do settings that is better for the equestrian sport. And that's the nice thing, we can set it for different disciplines, of course. The other thing which I think is really important in this case, I say that it mimics the horse, that is, of course, one thing that it's important. In this case, it's also open access, means that the drawings are free. It is actually an ASTM standard today. So that is important. It's an open thing. It is horse-like, means that it's not the ideal horse. And you tell me, I have had many ideas about how to improve it. But I think it's extremely important that measuring surfaces, to make that useful, it also needs to be needs to have a reference. And the only way to get reference is not to change your equipment. So that is one important thing. For now, we have used this for a long time on very many different kind of surfaces in different disciplines. And there is a huge database that we can compare to. So that's a little bit about the machine. So the next thing, what Raul was talking about, and which is really the important thing, is that it's very physically very different when the hoof impacts the ground. A small mass which decelerates fast, very different from the maximum loading phase when you have the full body weight of the horse planted on the hoof. So here in this situation, with horses moving in even moderate speeds, you would have 1.5 to 2 times body weight peak force on each of the 4 limbs. So, I mean, it's no wonder that we do have some sometimes orthopedic problems with our horses, right? Then, of course, we also have a phase with propulsion and push-off. So this is really the basis for the 5 parameters that, again, Raul already have mentioned: impact, firmness, cushioning, responsiveness, grip, and uniformity. So when we started this project, because this is based on my work has been based on research that was funded by FEI, the International Equestrian Federation, World Horse Welfare, and also Swedish funding bodies. One of the first things we did was really try to find terminology that can be used. So we didn't use the engineering terms, but again, as Raul was talking about, of course, there are newtons and pressures and everything behind this, and G's and so on. But I think for stakeholders in the equine industry, these are hopefully terms that make some sense. So to make that, I'll just explain a little bit more about the background to these 5 parameters, and also in this case, how we actually measure them. So the first thing, impact firmness, that relates to this hoof hitting the ground. And it's just at this moment, so basically just touching the ground. It's not more than a kilogram or 2 who actually hits the ground at this moment. And the mechanical hoof measures that with accelerometers. So impact firmness is measured in G, but we do translate that into a 1 to 5 scale to make it more easy to compare and understand also. So that's impact firmness. The next thing is cushioning. Cushioning is the maximal force that the horse experiences during each stride, and it occurs when you have the limb more or less the cannonball more or less vertical, like here. So it's in this situation. And on the robotic hoof or the mechanical hoof, that's measured with a load cell. So there, this is a number of newtons or kilonewtons that we actually measure in this situation. So it is, of course, very important to I go back to cushioning. Cushioning is it's a little bit of two different things, but because on the one hand, we need to have the damping properties, dampening of the maximal force. But we also need to have a surface or a footing that actually carries and supports the weight of the horse. So this is not, it should be something that is adequate. You see what I mean? The optimal cushioning is somewhere in between being very compacted and not too loose. So anyway, the dampening properties can also be affected by responsiveness or elasticity in the deeper layers. Especially in the deeper layers in the surface. And this is really something that we want to have. And this elasticity, it's not really primarily to get some energy back, even though you could think about that in that way, but it's really about the surface restituting. So when you have, for example, in show jumping, dressage, and equestrian sports, you want the surface to stay the same for many horses, then it becomes important. What we actually measure here is not energy return, but the timing of this response, because that needs to be tuned to the stride frequency or the speed of the load of the horse. Does that make sense to you? It's like a trampoline. It needs to be adjusted to your weight and how you want to jump off the trampoline, right? So I think this is interesting because you see all what I'm talking about, everything is actually important for how you perceive a surface. And I'll come back to this. This is another reason very many people ask me, is this a good surface when I have measured it? Well, I measure four different things, and the last one is the uniformity of it. And it really depends on the horse. It depends on how you have trained, your preferences, and so on. So what is good is not necessarily good for everybody. And this is perhaps a good thing for everybody working with this, because if you're a supplier or you're working with maintenance, installations, or whatever it is, there are actually different ways and solutions to make a good surface for a specific client, or for someone who wants, or for the client to order it, of course. So the force is grip, and that's perhaps not so everybody knows about and understands that grip needs to be adequate. We all know that hoof needs to slide a little bit. That's part of the horse's anatomical construction, to have attenuation of forces. That is, it's allowed to slide a bit, but of course it should not slip. And the way that is possible to measure with the OBST is, because it's not that well seen here, but it's actually an angle here. You will see it when you look at it closer here, between how it falls and the vertical. So you can actually see how it pushes material forward here, right? So when we measure the horizontal force and just make a quotient between the horizontal and the vertical force, we get a measure of the grip. Easy, huh? Straightforward. Good. Everybody is. You're happy to put up any questions whenever you want. Okay. So the next thing is then uniformity, which is basically the 4 parameters, how they are look over the whole surface, the arena, racetrack, or wherever it is. So now the interesting thing, and a little bit of, I think, which is important, the science behind this, does this make sense? Is it anything that is of value to horses or riders, trainers, or whatever? Well, I mean, so far I only discussed out based on a biomechanical perspective, but what we did was that we measured the number of 5-star jumping competitions, and we had riders evaluate it, not whether they thought it was good or bad, but now I just have one example from the impact firmness, whether they thought the impact firmness was to the soft side or to the hard side in relation to a number of other arenas on that level. And the interesting thing was that if you look at a single arena, blue and red representative OBST and subjective evaluation, it was a little bit all over the place. But when sorted in increasing order and looking at the trend line, it is very, very close. So what this says is 2 important things. It says that, yes, we do measure something that a large group of riders in this case actually perceive when it comes to the quality of the arena. But it also tells us that it's impossible to find one rider that is good enough to assess these. So we do need the measurement, even though we measure something is actually something that riders can feel. Okay. So then I think we can go over to some of the more practical stuff. So this is difficult to read for you, but really what I wanted to show here, I used this when we did presentations at the Olympic to just explain everything that I just told. But when we present it, we use this box plot, meaning that this small blue square that is representing all the drops that we make on one arena, and the red one is the median value, the box is the 50% middle. And the green and yellow and red color is based on this rider evaluation, because after they evaluated all the different parameters, we asked whether they liked it or not, and that way we could create some thresholds. So now let's get into the more practical part of this, or the applied part of it. So this is from Tokyo Olympics last summer. And it would look like this. This is Penelope Lepro from France. Just interesting, just look at, I mean, when you do these, I look at these high-speed videos, you just kind of see the forces that we're actually talking about, right? And of course, you will see the same thing. Here it's the height that create high forces, but speed will also increase forces, of course. And measuring with the OBST, and look at how the surface actually responds. You see how you literally can see how the forces are distributed because the ground is moving around the impact place. So here's the summary. It's difficult to see it for each. You don't see what is the categories, but I'll explain it to you. So this is one of the presentations that we did for the riders, coaches, for everyone during the Olympics. So that was an official report. And to make it relevant for them, we have in this case the actual day that we were looking, in this case the 6th and 7th of August. We compared it to the test event that was held 1 year before, because of a lot of riders would know about that. And we also compared it to Tryon, which was the World Equestrian Games in 2018. And we compared it to the Olympics in Rio and the Olympics in London. So you can see there, if you start looking at all these different panes, that it is really quite different. Although all parameters are within green, so that means that they are within the range you would see. But the characteristics of them, without going into any details, are of course quite different, meaning that different riders would like it more or less. But just being able to show that this is within the range that you normally would compete on was a very, very important information for the organizers, because it kind of cut off a lot of discussions. You can imagine how it is when it's Olympics and you everybody is looking for something to explain why they didn't win, right? So Ollie, I'm sorry, I've been talking a lot. Do you want to comment anything on that? You were involved in several of these previous events as well. We maybe come back to it, but is there anything you would comment right now?
Yeah, good morning, everybody from Kuala Lumpur. To comment, actually, we see the difference between Tryon and London in the cushioning, which I find very interesting. And that one we have to go a little bit into the background because London was very, very unique, built on a platform, and we got a lot of response from this platform. And Tryon actually at that time was we had a very good layer and a completely new designed footing, which was very nice to see. how it worked, and later on Lars will pick up on the Triumph footing, how this one had to develop to get to the standard where we want to have it. And if you see especially in the cushioning, but also on the impact firmness, the difference to the other events, the Triumph one is basically our benchmark footing where we want to go. While we have to see that the other ones are very consistent in their levels, and this one gives us a good feeling where we have to go, because London, Rio, but also Tokyo got good response from the riders. So the variation is very interesting, and to maintain it on this level becomes interesting, because we had London the weather was more moderate, while Rio, but also Trine and Tokyo actually were very similar. It was either boiling hot, and then we had thunderstorms with massive rainfalls. So yeah, that was the interesting and challenging part from the maintenance side. And what I personally like to see, the responsiveness as well, which was in Tokyo a little low, but that was also due to the characteristics of the footing.
Okay, we'll come back more. I mean, it probably looks like a lot of information when we start talk on it about it like here, but we'll go into some more details to make it a little bit more simple. I'll take one more from Tokyo here.
And this one shows a little bit. We have these different arenas. We call it arena A, B, C, the field of play, final, warm up, and the indoor arena, which all had the same footing mix, but there was a difference in the depth of the layer. And the interesting part was arena A and arena B had a difference of just an inch more of footing in arena B. And if you look at at all values, basically impact firmness, cushioning, responsiveness, that this 1 inch made a huge difference in the values we measured. We had a much nicer cushioning with impact on the impact firmness side as well, much nicer values just by increasing the footing layer by 1 inch. And arena C was set up almost the same like arena A, but still the values are slightly different, especially on the cushioning and responsiveness side. But that one was related to the fact that arena C was mainly shaded during the day, and that means we could keep a lot more water in the footing, which created these better values compared to arena A, which was in full sun all day. And so this shows us that maintenance is really the challenge in these conditions, in these hot and dry conditions. Because in arena A, the moment we watered, we got to a level like C, but if you went there half an hour later, it went up to what we measured basically. So the higher values on the cushioning side, for example.
So everybody is following that is A, B, C, what we call field of play in the main arena, the warm up, there was an indoor arena, and S. You follow the pictures here? Okay, very good. So again, you might ask yourself, is this relevant? I mean, these changes? Yes, I mean, the difference, especially I would say in cushioning, when they start jumping the horses, riders who are, I mean, I don't say all riders, but some riders are definitely saying, yeah, I can feel the difference between these two arenas. So we're not talking about something subtle that is not relevant. Riders can feel this difference, even though we are within this green area. I think that's one thing. So the take home message from here was that exactly the same sand, but mainly, number one, the difference between the top layer thickness gave us consistently these differences, especially in impact firmness and cushioning, even though it could be partly handled with maintenance. We saw this consistently. So another example then that you were talking, this was from Tryon, and you can comment this one again, Ollie. So what we see, what we see here is from the main arena from September 3rd, and then all the way up till here we are at September 19, 2021 at the end. So this is during before the competition, and this is during the show jumping week in Tryon. Yes, Ollie.
Yeah. So yeah, what we see here, the first plots were basically measured right after installation. So the footing was just installed and got the first initial maintenance, and the value for the cushioning was still very low, and actually too low to have a competition on it. And the nice thing is we have this period of about 8 to 10 days where the footing just slowly improved and went into the green zone, and then within another 4 or 5 days it picked up and went to a level where we ideally want to have it, nicely almost in the middle of the green zone. And then it stayed all over the entire event more or less on the same level. And that is very unusual when it comes to see, or when you see the traffic and the activities on the arena. When in Tryon, for example, we had at one point, I counted 17 golf carts running around in the arena during the setup of a course, which is, golf carts are one of the best compactors you can have. And still we didn't see any major changes in the cushioning value. So that's why I would say this is still my benchmark footing, really forgiving to these kind of activities. Tokyo was different in that sense. We really had to work hard to eliminate the impact of golf carts and other heavy vehicles. Later on, we have a nice example in the slides as well.
Yes, so that's definitely, and I think everybody in this industry knows the importance of the sand and the sieve curve, the distribution of the sand. So we can go on to that, actually the interesting part from the difference from Tokyo and Tryon. So what we see here now is a long series of measurement, in this case from specifically the field of play in the main arena in Tokyo. And what I want to point out here is you can see here there is a tendency towards compaction when it comes to both cushioning and impact firmness. When we started up, it was a little bit off in responsiveness. But what I really want to point out is something is happening here, and that was more specifically on the 1st of August. And what happened, Ollie?
Yeah, what happened was, and that was the interesting part, we normally watered the arenas just in the morning by sprinkler, and just at the late evening using sprinklers due to restrictions from the neighborhood noise. It was the main complaint. So for the rest of the day we used a water tanker. Lars will show photos later, which basically flushed the footing. We really had like a flash flood on the footing, and then we had a breakdown of these tankers, or they said, yeah, one tanker had a breakdown, and they said, yeah, they had to repair that one, and there were a lot of excuses. But 2 days, Lars and we went to see Forest cross country area, which was about 1 hour away from the Olympic venue. And on these 2 days, they just used sprinkler to water the arenas. And so the way you maintain footing or you water footing, especially, or on this footing, I'm not sure if you can say it for all footings, but I see it in many occasions that watering by sprinkler is not as effective as using a tanker. Probably on Tokyo, I would say we lost a lot of water because we had a humidity around 40% air humidity. So by shooting the water through the air, you lose a decent amount. Then it was quite hot and the sand got quite hot as well. So the moment the water touches the fine mist of the sprinkler touches the footing, we lose a significant amount of water again. So the effective water in the footing to create good values was probably minor, because the technician said, oh, we sprinkled the same amount of water you use with the water tanker. But the difference was measurable, that, yeah, there is a difference between water tanker and sprinkler watering.
So again, the question is, was this just something we measured? No, when we came back from the eventing, there was really fuss going on in the Olympic Village, you know, with the riders started complaining, we are not satisfied with the surface. And then I must say, I appreciated the decision from FEI, but it's because they said, okay, let's present this data and show them. And I had a presentations for the chef d'équipes and explain, this is what it looks. You are correct. We are getting up in the yellow area. We think we know what it depends on, and we have to plan to fix it. Any questions? Quiet. Everybody was satisfied with it. So this is, of course, very important for the organizers in this case. But it's also something showing that the measurements are relevant. So coming to this, what we don't show to everybody, but what we really work with on a daily basis in a situation like that, that is, of course, the measurements, the functional properties, but also looking at moisture. And I think this is something that comes through all the time. Moisture is the single most important maintenance procedure to work with. So this is just a TDR measurements from one single days on the main arena, on the different arena that we have discussed already. And the interesting thing is, of course, when you start combining the information with the moisture, controlling the moisture, if there are any difference in the moisture, the measurement, and of course also other maintenance related things, which machines you use, how you're setting your machines. In this case, it's the normalized value for cushioning. And I just made a hand writing here that it's a bit lower on this side. 2.2 is the average in this red circle and 2.9 in this part of the arena. Do you want to comment this one also, Oli?
Yeah, and this one again goes back to moisture content, like Lars said. And we also used in the field of play, we used sprinkler and touched up with the water tanker, because we had limited, we had many restrictions when it came to watering, amount of water available, etc. So the water we sprayed with sprinklers basically were taken off from the amount of water we can use for the water tanker. But we had some days it was more windy, and we had a wind from the, if you look at it from the upper left to the, oh, good morning, Johan, my son is coming, sorry. So this wind blew actually water from, and that is another disadvantage of sprinklers. They are very sensitive to wind. And we see that the moisture actually was nicely in the bottom right, while the bottom left didn't get enough. And that one was nicely reflected by the measurements of the OBST again.
Yes.
Okay, so we see these are the water tankers we used in Tokyo. It's a 10,000 liter tanker with Galaxy tires on it. So the impact of or the compaction of the tires is comparatively small, and we measured it with the OBST, the difference, and you see a slight difference in the values, but not really very significant. And the nice thing is you get a comparatively even spray with the tanker in a good width. And the other advantage is that by adjusting the speed of the tractor, you can adjust the amount of water you spray on the underfooting. So with one pass, you apply the amount of water you want to have in a nice width. This tanker, if it was fully pressured, we achieved a width of about a 16-meter spread. So with a few passes, we just covered the whole arena evenly. Okay, and this one is a tanker I used in Canada, and this shows exactly the spread as well. And this was a Derby field where the grass was about to die, and the sprinkler didn't bring enough water, so I used the tanker to water it. And just as an illustration to show you how even these tankers can spray. This is a very big boy. It's a 3,000 UK gallon tanker.
Okay, so another interesting thing is, of course, I mean, what I really like with the OBST is, of course, that this is mimicking a horse, so it doesn't really matter what kind of surface we are testing, whether it's a turf or whether it's a synthetic or a pure sand or a fiber sand surface. So this is just measurements from the Olympics again, and this time it's the eventing course. So this is, of course, interesting to look at over a larger area when we come to that kind of courses. And if you wonder why it looks so red here, that is because it's the water fence, and there was no water in it, so we could measure it. and of course, you want it to be very compacted in the bottom of the water fence. So I think that is a little bit of examples how we can use the OBST for testing, but I think it's not only competition. So from the competition point of view, it's important to be able to tell for the organizers to say, okay, this is what we want to aim at, to be able to tell that to riders, organizers who is coming there, and to be able to share that information. And of course, from the training perspective, it's important to know, I want to train for what I'm supposed to do. Because the horses, we need to remember that it's biology, and the horses are really very adaptable to different surfaces. And I again say that I'm a little bit reluctant to talk about bad and good surfaces. There are really no poor surfaces. There are only poor use of surfaces, to be honest. But to be able to train your horse for a competition, you need to know what you expect, and then you can adapt your training to that. And then again, if you are an owner, I mean, my vision with all these measurements, that is that a client who wants to install, whether it's a private client or anything else who wants to install a surface, should not decide whether they should have a specific sand, fiber, or any other content. They should be able to say, I want to have a 2.5, 2, 3, 4 surface on the 5 parameters. That's functionality. That's how you would order a car, right? You want the car with a certain accelerations, with automatic or manual gear, right? You don't care about the details. The details, that is the sand. How we can't expect that lay people can understand those things. So this is a way to communicate, which I think is very important, which would make it easier for both client and for suppliers in this case, right? Because from the supplier point of view, it's very difficult to try to interpret what the client wants when they say they want, I want a good soft surface, or I want it. How do I interpret that? You see what I mean? So this is really the challenge, that is to being able to communicate, and that's what we can do. And of course, this comes into discussions around renovations and maintenance as well. So most of the things we have been talking about today, you can read about in this Equine Surfaces white paper and also in what we call the Equestrian Surfaces Guide. These are possible to find on FEI's homepage, and there is a number of research behind that from both UK, US, and Sweden. Questions to me and Ollie?
So my question is, do you have a standard moisture level?
No.
It all
No, my favorite, and I think many of you have probably used that is the beach. If you have a specific sand, if it's too dry, it's getting loose, you have a spot where it's very nice and you have the cushioning that you want, and then it starts to float around. And that part is different depending on which sand you have. So the answer is no. But in
just to give you a quick example, in Tokyo, for example, we had a moisture content of about the ideal moisture content was around 27%, while we have another footing. Okay, it's an indoor footing, but still it has its optimum around 22-23%.
Thanks, that does answer our question.
Other questions?
Has the FEI established standards from your work for, for surfaces that are used at a certain level of competition?
if they have
Standards.
yes, so yes and no. So this is really what I've been working for a decade, literally now, to establish this standard and the thresholds. So the thresholds that I have showed here is the ones that we use together with the FEI when it comes to Olympics and World Championships. And the intention of FEI is to roll this out on 5-star level for a start and then go down. But it's not yet officially a requirement. But this year, I will measure all World Cup and the Nation Cups in Europe with this method and with this standard. And that's, I mean, that's of course, this is the way. I think when we start doing this and make it officially, everybody and every stakeholder will start to learn to understand that. So we will understand these parameters and have an idea about this 1 to 5 scale. And hopefully that will make things much simpler for everybody. How are you measuring the moisture? With a TDR.
I'm just curious how you determine how many points and where exactly you drop the OBSC throughout different arenas. Doesn't matter depending on dressage versus a show jumping course.
So on an arena, from a general assessment point of view, I would do approximately a 15 by 15 meter squares. But the interesting thing is, of course, you can use it also for specialized questions. So if you really want to know the micro changes, you would make several measurements there. Or if you have a specific problem, you would go actually measure there. Or somebody wants to know, oh, I want to look at the takeoff on the landing of the fences, I can do that. But the general assessment is a 15 by 15 meters squares.
Well, another question. In your conversation, you mentioned that you top dressed one of the arenas with 1 inches of sand, and it made a huge difference in the cushioning. My question to you is, for the majority of the horse show competition venues that you go to, what is your recommended sand depth for that top layer?
Ollie?
Yeah, at the moment we are aiming for 5 inches of footing layer for events. It also depends what kind of layers you have underneath. If you go to an indoor where you have, for example, the concrete floor, I would recommend even more 6 or even 7 inches of footing to create the best values. But it's also an economical problem, how much you can afford. But 5 inches, I would say, is the minimum.
When you're measuring your moisture content with your TDR, what depth are you measuring at?
I'm using the 3-inch probe.
Your type of equipment on the takeoff or landing, does that have to be groomed prior to measurement? Or can I run 30 horses over a jump and then go measure the takeoff and landings to get a competitive repeat reading?
It depends. That depends on your question. What do you want to know? If you want to know what the horses do, you measure when the horses have been there. If you know how well you can reestablish your surface after maintenance, then you measure then. So simple as that. And this is of course very important, that you need to know under which circumstances you are measuring. And that's what I'm saying. You can ask a number of specific questions and assess them with the measurement. But when I do the general assessment, just to get an overview, I do this pattern of 15 by 15 meter and try to look, not find bad or poor, bad or good points, but representative points.
So you try to test an area that is groomed rather than an area that has been ridden.
In the standard case, I would look at a groomed area. Yes.
Okay.
Are there any other questions? Well, thank you very much, Lars. And
Thank you.
Ali, thank you for calling in.
Yeah, welcome. Thanks for having me.